You can start now.
Good afternoon, everyone. This is Dr. Piyali Sengupta from Department of Civil Engineering of Indian Institute of Technology, Dhanbad. Today, we have assembled for the second live session of our course on bridge engineering. If we talk about bridges, we know that bridges constitute a significant portion of the national economy of a country, and they also serve as a foundation for the infrastructural development of the country. There are several new bridges that are required to be constructed in any country, and also numerous number of existing bridges are present which are required to be repaired or retrofitted across the world. So therefore, there lies a motivation behind studying a course like bridge engineering. So this course on bridge engineering aims at knowledge development of the principles of engineering mechanics, load transfer mechanisms, analysis methodologies, design principles, damage mechanics, failure mechanisms, construction aspects, inspection, maintenance, repair, and retrofit strategies in the domain of bridge engineering. Also, there are advanced topics in the domain of bridge engineering like fatigue and fracture in bridges, use of special materials like safe memory alloys and special concrete for repair of bridges, 3D printing technology for bridges, high speed railway bridges that are also being introduced in this course. We expect that after successful completion of this course, the students will be able to equip themselves with the fundamental concepts, acquire in-depth knowledge on analysis and design of a wide variety of bridges. They are expected to understand the field-based construction, inspection, maintenance, repair, and rehabilitation techniques of bridges. Also, they will make themselves familiarized with the emerging global trends in the domain of bridge engineering. Here, we have distributed the course into 12 weeks program. So, in each week, we are introducing one topic, like in the first week, introduction of bridges were introduced. Subsequently, in the second week, reinforced concrete slab bridge decks were discussed about with numerical examples along with the design examples, design principles in the analysis of the reinforced concrete slab bridges. Subsequently, in week 3, box culverts and pipe culverts were explored. In week 4 and week 5, there were discussions on steel truss bridges and plate girder bridges. In week 6, bevy of special bridges like arch bridges, suspension bridges, cable stayed bridges, and balanced cantilever bridges were introduced. In week 7, pre-stressed concrete bridges and composite bridges were introduced. Subsequently, in week 8, rigid frame bridges and continuous girder bridges were covered. Week 9 was focused on special components of bridges. We know that bridges can be classified into three types of components: superstructure, substructure, and foundations. Week 9 were focused on substructure and foundations, where the discussions on piers, abutments, and foundations were made. In week 10, special components like bridge bearings, joints, and appurtenances were discussed about. Week 11 is going to be talking about construction, maintenance, and rehabilitation techniques of bridges, while week 12, as we had discussed just now, are going to be regarding the advanced topics in bridge engineering. So, as per the course, I am sure you all are now familiar that after a week's video lectures are shared with you, then an assignment is shared with you guys where you are supposed to complete the assignment, and the marking scheme by now I'm sure you are familiar about, that you are supposed to complete 12 assignments coming from each of the 12 weeks. Now the average assignment score will be comprising 25% of your total marks, and that 25 percentage assignment marks will be coming from the average of best 8 assignments out of the total 12 assignments, and the exam score will be taken as 75 percentage of the procured score. So that's how total marks, that is the final score, will be coming from assignment score and exam score, where assignment score will be 25 percentage of the total score and exam score will be 75 percentage. So these were some basics, the course layout plan and marking scheme for this course. Now let's look at the questions. Whenever you are getting a lecture note, in the last slide you will be able to see the reference page where the course materials are the references from where the course materials are developed has been mentioned. So you can refer to the books or the codes that is mentioned in the reference section of each of the week's lecture. Also, if you have any queries from the lecture notes, whatever in the video lecture that you are getting, you can post your queries in the discussion forum. So in that discussion forum, we are supposed to answer, and we keep on answering your questions on regular basis. So as we can see that till now there's no questions available. So let me see if there's any question remaining in the, if any students have posted their queries in the Google Sheet. So I can see that there's a student named Rajesh. He has mentioned that he has no question. So when we were talking about the certification part, in the final score, as we have said, that 25 percentage marks are going to come from assignment and 75% marks are going to be coming from the exam. So in total, the students are subjected to get a score of 40 so as to get the certificate. Also, in the assignment score, they are supposed to be getting 10 out of 25, and in the exam score, they are supposed to be getting a score of 30 out of 75. So, three criteria are required to be met in order to be eligible for certificate under this course, or as per the rules of any NPTEL courses, that in the assignment you are supposed to get 10 out of 25, and in the exam score you are supposed to get 30 out of 75. Also, the total score should be at least 40 out of 100. Then only you will be able to get the certificate. If you don't meet the first two criteria, that is you get less than 10 in assignment or you get less than 30 in exam score, so then even if your final score is 40, you will not be eligible to get a certificate. The exam date has been scheduled to be 26th of October 2024, and the exam is going to be conducted in two sessions. The morning session of the exam is going to happen from 9 a.m. to 12 noon, while the afternoon session is going to be during 2 to 5 p.m. So here we are waiting for the queries from the learners. Okay, I can see there is a question that a beam is said to be cantilever when it projects outward, supported only at one end. A cantilever bridge is generally made with three spans, of which the outer spans are both anchored down at the shore and cantilever out over the channel to be crossed. So this question is made by Shweta. Yes, a beam is said to be cantilever when it has one support at one end and the other support is free. Also, when we have statically indeterminate structures, if we go for that configuration, then you might have learned about a concept called Prof cantilever, where it will be in the free end, it will not be free, rather there will be a roller present. So now coming back to cantilever bridge, the cantilever bridge is a special configuration whose full name is balanced cantilever bridge. So the balanced cantilever bridge, if you this was discussed in week 1, also it was discussed in detail in week 6, that it has three types of span. It has anchored spans, that are the outer spans. Then it has a cantilever span, and in the cantilever end inside there is a suspended span which is balanced by the two cantilevers. Okay, so here it is balanced cantilever bridge. It is actually, the fundamentals is the cantilevers are balancing the suspended central span. So that's why it is said to be a balanced cantilever bridge. And as if you go through the lectures again, you will see that balanced cantilever bridge is one of the latest configuration of bridges which was evolved much later after the Second World War. So it was developed after that. It required simplified process for analysis. The analysis skills required to go for analyzing balanced cantilever bridges are simple. So that becomes computationally efficient. I hope this answers your queries. Bridge is constructed over the channel to be crossed. Now it is going to be a bridge that is constructed to cross a channel. That means that you are talking about a river bridge or a bridge that is above a water body. So we may have bridges that is crossing a valley. We may have a bridge that is crossing a railway. As we know, if we recall the first lecture, there we said about the definitions of bridges. So whenever we have any obstacle and the bridge is crossing that obstacle without closing the way beneath, so that obstacle can be in any form. So when the obstacle is in the form of a water body, be it a river, so then we end up on getting a river bridge. Or if we have a railway lines are there and we are crossing them. So subsequently it ends up being that type of a bridge. So the concept of balanced cantilever bridge is not only applicable to river bridges, it is applicable to any other bridges, any other special cases where the obstacle can be anything even other than water bodies. So I can see that there's one question. I have a question. Mr. Raghavendra Kumar has said that I have a question from stressing part of PSC girder of or segment in bridge. After calculation of modified pressure and modified elongation, then we get three conditions like minus 105 percentage plus 105 percentage and 100 percentage. Can you please, I think you wanted to mean that can I go for elaborating this. So actually when we talk about pre-stressed concrete bridges or pre-stressed concrete bridges, we know the speciality about pre-stressed concrete bridges are we tend to use it. What is the motivation? Let's first talk about what is the motivation behind using pre-stressed concrete as a material. The main motivation behind this is like when we constructed, when we developed reinforced concrete. Why? Because we know that concrete is weak in tension. So then we strengthen concrete by providing reinforcement bars. Subsequently, the problem with reinforced concrete is presence of early cracks. That happens due to lack of compatibility between the concrete and the steel bars. So then we ended up with pre-stressed concrete. That was the invention. Now, for pre-stressed concrete, we are required to come up with high strength concrete and high strength steel. The reason is very simple because in the pre-stressed concrete girder section it has been mentioned that there are sources that is in the form of losses. So if we don't have high strength steel and concrete present in the construction of pre-stressed concrete section, then when we cannot avoid presence of losses, then we end up to getting something that is not useful. So we know that losses are inevitable. We can't avoid them. We can minimize, but we can't avoid them. In that case, we are supposed to come up with high strength materials so as to end up with a final component which is strong enough. Now, coming back to the calculation of the pressure and elongation, we get three conditions 105, 1 plus minus. So here these are about the numbers and what is, I mean, from which dimensions, how it is being obtained, that needs to be elaborated so as to be. Now, when we talk about any bridge specifically, we know that in module 1 we had discussed about like we from selection of the site of the bridge, from selection of the type of the bridge to be constructed to the dimension of the bridge, everything is dependent on so many factors. Which material to be used, that is also required to be decided accordingly. Now, when we go for design, we not only we assume that the type of the bridge we have identified, the site of the bridge we have identified, and we are looking into the component dimensioning. We are looking into the component dimensioning and seeing that what is feasible and what is feasible in terms of being cost efficiency and also the strength. We also need to take care of the serviceability aspect. We can't avoid that. So when we come to the design part, one major component is the loading that is present. So we are required to see what is the loading that is present in that bridge. So based on that only we will be able to say that okay, this is the way that we are going for the calculation of the pressure or the load calculation procedure. So if you have any specific query regarding any segment of the lecture, please mention that in the discussion forum that okay, you have doubt in this part at this minute with the time step, and then you will be getting the answer from the discussion forum. So please drop the question with the time step so that your question becomes clear. Okay. Okay. So we can see that there's no more questions present. So even in the neither in the Google Sheet and nor in the chat portal. So we are ending the live session here, and I'm sure that this course is going to be a good learning experience for you guys. And if you end up to having more questions after the live session ends, please feel free to put your questions in the discussion forum. So we are going to respond back to you. Thank you so much. So we are ending our session here. Thank you.